Hello, GED students. Welcome to our next data analysis lesson. Today, we're going to hone in on types of charts and graphs. Today, we're going to focus on the types of charts and graphs that are frequency focused, okay? We'll be looking at a few different types. So, in order to understand what I'm talking about, we'd better understand that word frequency. So, what is a frequency? Well, this is a common English word. Guys, if I ask you what a frequency is, any ideas?
Most common?
It's how often. So you could have a high frequency, then you'd be the most common, or you could have a low frequency, then maybe you didn't happen very often, but it's that idea of how often something happens. So from the Merriam-Webster Online Dictionary, I got this definition here: the number, proportion, or percentage of items in a particular category in a set of data. But the idea here is just how often something happens. There's actually quite a few different types of charts and graphs that focus on frequency. We're going to look at some examples of all of these today. So bar graphs and histograms. You guys, I'm sure, have seen bar graphs. They look like, you know, those graphs with all the bars on them. Hence the name. Okay, not too complicated. Tables, not all tables have to do with frequency, but the one we're going to look at today, known as a frequency table, does. So when I talk about tables, tables have rows and columns full of data. That's the idea of a table. Pictographs. Pictographs are actually kind of an elementary, usually used for younger children type of graph because they're pretty easy to understand and look at. But they are fair game for the GED. They should show up. They could show up, I should say, so we should look at them. There's also line plots, and a lot of people are not as familiar with line plots, but it's definitely one of the GED's preferred types of graphs. So what a line plot is it just looks like numbers, a number line, and then there's a certain number of X's above each number on the number line to tell you the frequency with which that particular number or item occurs. The last one we're going to look at is a stem and leaf plot, and those are the weirdest. We'll take some extra time to look at those. For a lot of students, this lesson is the first time they've ever seen a stem and leaf plot. They look a little weird. They're not actually hard. You just need to have seen them before in order to understand them. So those are the types of graphs we'll look at today. And again, they're all going to have to do with frequency, with how many or how much of something. So, you know, why do we use charts and graphs in the first place? We use them to take a lot of data and to organize it. So that's where a chart or graph starts. It starts with some data, some information. So let's go ahead and look. I've got some data for you. Okay. So here's a data set for us. So I'd like you to imagine that I asked a group of GED students how many GED subject tests they've taken and passed, and they gave me the following answers. So right now, this slide to me looks like a bunch of visual vomit. I have tons of different people's names. I have a bunch of females, their names, and this number next to their name. And of course, this number represents the answer to my question: how many GED subject tests have you taken? So you can see, you know, Alice hasn't taken any or passed any yet. Betty's passed 1, Carol's passed 3, and so on and so forth. Right now, this list is accurate, but not very useful because it's not organized. It's just information everywhere. And so we can use any one of these types of frequency charts and graphs in order to organize this information. Okay, and what we're going to look at organizing this information on today is based on the frequency of each answer. So basically, how often I got the answer 0, how often I got the answer 1, 2, or 3. Okay, so let's look at some examples. So first example I made 3 different bar graphs with the exact same data. Okay, so really important thing when you guys look at bar graphs, please read the axes. Do you guys know that word? Do you know what axes or an axis is? Okay, this is some language we need to understand. This is some vocab that is important to the GED. We have both a horizontal and a vertical axes. When I talk about more than one, they're axes. When I talk about just one, it's an axis. So we have a horizontal, which goes left, right, and a vertical axis on a graph. And basically, at their most simple, they're used to compare two different things. So like, for example, let's look at this first graph, the one that's only blue. We can read this horizontal axis tells me the number of tests passed. So there's my numbers, 0, 1, 2, or 3. And then my vertical axis, the one going up and down, tells me the number of students. And we can see that that guy goes from 0 to 20. So I can see, like, from this graph, number of students who passed 0 tests was 20. Now, I could have gone back and counted that in my ugly data set, but it's so much easier and clearer to see here. Okay, and so you guys just humor me a little bit. According to this first graph, how many students have passed one test?
12.
It's close to 12, isn't it, Maricela? But be really careful. One of the hard things is that number is not right on the 12 line. It's a little bit underneath it. So one of the hardest things is going to be to determine those kind of in-between numbers. What do they represent? Well, in order to fully understand, let's take a look at the way the axes are labeled, or this axis is labeled. This guy is 8, and this guy is 12. How much of a difference is that? How much of a span is that if I'm going from 8 to 12?
4.
It is 4. So that means that total space is about 4. So I could visually break this space into 4 equal pieces with my eyes. I will do it first in half. That half would be halfway between 8 and 12, the 10 mark. And then I could break it in half again. There's 9. And there's 11. Can you see what I'm saying there?
Yes.
Okay, so now, what do you think? How many students have passed one test?
11.
11, exactly right. So obviously we just kind of stumbled upon one of the tricky things about these bar graphs. That would be a weakness. Sometimes it's hard to tell exactly what number is represented, especially when there's a big jump between the labeling. So let's look at some of these other bar graphs. They're still bar graphs, so it's still the same basic thing, but take a look at this guy. This one I was able to give more information than the last one. It's the same data, but I know more about the data. Can you guys see the addition of information that I got here? What new thing can I see in this graph? If you're not sure, check out this key down here. Do you see what the two different colors tell me? So I can see here, maybe my screen is too small to see, but this blue represents the females and the orange represents the males. And so even though I still have the same basic thing on my axes, I still have tests passed versus number of students. I was able, by using two different color bars, to slip in an extra piece of information, you know, which was the female and which was the male. This is known as a clustered bar graph, where we do the colors right next to each other. I've clustered them. I've put the blue next to the orange. Or I could do similarly the same kind of a thing where I stack it. This is a stacked bar graph. So that's some way to get even more information on a graph. Now we have the two variables that we were talking about, this number of students and how many tests they've passed, but we've combined it with whether or not they're male or female. And so we're able to get more information by either clustering bars or stacking bars. But this is not the only way. This exact same data, so this same data, all these people with their numbers of tests passed could be represented not only with a bar graph, but like I said, there's other ways to look at frequency. We could also represent it with a frequency table. I really think that all GED students need to star and highlight frequency tables. This is something that you guys really struggle with, and it shows up when it shows up on the GED most often. I see wrong answers. Nice. So there's something we're not understanding about frequency tables, okay? But again, frequency tables tell us how often the data happened. So you're going to see at least two columns in a frequency table. You'll see a column that tells us about the data. You'll see a column that tells us the frequency of that data item. So when I look at this first frequency table, I said one of them represents the data. So remember, in when you're talking about data, data is the answer to whatever questions we asked. So I asked all my students, how many tests did you pass? So this column here, numbers of tests passed, this is my data. in this particular frequency table, the data comes first. It doesn't have to be in this order, but that's the data because that's the answer to my question. That's the information I collected from them. I tried to figure out how many tests have you passed. But then we also, a frequency table has a column that tells you how often or how many number of times, the frequency that you got that data. And so I do see that here. I see that 20 students said 0. So what does that mean to us? That means there's actually 20 zeros in my data set. There were 20 people who said 0, so there were 20 zeros. There were 11 ones, 5 twos, and 16 students who'd passed 3 tests. Okay, so one of the columns will be our data, the other one will be the frequency of that data, how often we received that response. And I just wanted to show you that I don't have to just break it down by students, just like with the bar graphs, I can get more information here. So on this one, I see number of tests passed, females, males. You tell me, which column is the data here?
The number of tests.
Absolutely, there's the data. Now there's an interesting question. Which one is the frequency?
I think
The males and the females?
Yeah, these are both frequencies. Exactly right. This is the frequency of the females giving that response, and there's the frequency of the males giving that response. And so we happen to have 2 frequency columns in this particular table. But I just wanted to kind of go through this with you because we need to realize that just because it's a frequency doesn't mean it'll be labeled frequency. We have to understand what frequency means, which is how often a data item was given or how often we heard a certain response. So guys, do you see any strengths or weaknesses of this representation? How do you feel about frequency tables? So what do you think is a strength of this way? What's a good thing about it?
I think it's more organized.
Yeah, it's a good organization. You can put a lot of info in a small space. I saw a frequency table the other day that summarized over a million data items. Woo! That would have been a gross list to look at, a million data items, but they were able to put it in a little table because they had so many repeated answers. Do you see any weaknesses of this representation? Well, I do. I see one. Here's my weakness. It's not very visual. Just real quickly, it's going to be a little confusing because my markings will still be there. But this last one, we looked at that bar graph, very easy to tell visually which one's bigger or smaller. You have that lovely visual representation. But this one, we don't have a picture. We have to kind of think about each number. So we've looked at bar graphs. We've looked at frequency tables. Next, we have line plots. This is a line plot, and this is one that frequently comes up on the GED. So what is a line plot? A line plot looks like a number line, so you can see I have a number line down here with certain categories in it. So this particular one has the categories 0, 1, 2, 3, or 4. And the way that they use this number line is they just use little X's to represent each data item. So each one of these X's represents a data item. So you can see a lot of students passed 0 tests because I have a lot of little X's there. And not that many students have passed 2 tests. I don't have very many X's there. So pretty simple, but I just don't want the first time you see this to be on the GED and then you lose your mind like, oh, what is this? I've never heard of a line plot before. So looking at this, do you guys see any strengths or weaknesses of this representation? So how about strengths? What are some good things about this way to look at the same data? It's the same information now.
It is more visual.
Yeah, real easy to tell in a hurry, you know, compare the sizes in a hurry. That's really nice. Do you see any weaknesses?
Yeah, it's too hard to write it.
Yeah, we have too much data on this particular one. You know, there are so many X's. I was even trying to count the X's and I kept getting lost. I'm like, do I have 15 or 16, you know? And so it was a little frustrating that way. So yeah, that's definitely some weaknesses of that sucker. It's really only good for small data sets. Another way to look at the exact same data, okay guys, I plotted the exact same data on this. This is a pictograph. So a pictograph, you can see just uses a picture to represent something, but be really, really careful. Unlike a line plot where each X always represents one thing, on a pictograph, the picture might represent one thing or 5 things or 1,000 things. So it's super important to look at the key. The key here will tell you what each picture represents. So we can see in this, each time I see a star, it represents 4 students. Okay, guys, let's take a look at this pictograph, and I'll ask you how many students have passed 3 tests. James is liking this particular graph because it's so visual, and I agree with you, James. That's definitely a strength of this graph. So, but can you guys tell me how many students have passed 3 tests?
16.
16, absolutely. I totally agree with you. Maricela, how'd you get 16?
Because each star counts 4 students.
Exactly, so I'm counting by 4s. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Real nice. Okay, but now try to answer this. How many students have passed 1 test?
11.
It is 11, but hard to tell. You know, you have a part of a star. You're like, oh, is that 10? Is that 11? I'm not sure.
It's more than half star.
Yeah, you said more than half, must be 11. Very nice. But that can definitely prove to be tricky for students. James told me a strength. He said it was a really good visual, really good for visual comparisons. I absolutely agree with him there. How about a weakness of this particular chart?
It's hard to write like half star or
It's hard to look at the middle ground. But, you know, in one way, it's better than the one before because I can get more information. It's, oh, James said it's more anonymity. Oh, that's like a downfall. Like it's, you don't really know who's who or exactly what their things are. Yeah. But what was I saying? Oh, unlike the last one, it's not quite as messy. So I was able to take a lot of information and using that key, you know, bring it down to a smaller symbol. So that's nice. That's actually a benefit. I can get more data onto the same graph by using that key to represent more than one thing. We've looked at now some different kinds of ways to do frequency, but I want you to look at another data set, a different data set that I would treat a little differently, okay? This time, instead of asking the students how many tests they've passed, I asked the students their ages. Take a look at my data here. When I asked my students how many tests they'd passed, you know, I only had a few answers. Either they had passed 0, 1, 2, or 3 tests. Because if they'd passed 4, they weren't in my class anymore. And that's all the tests there were, you know, so I had a very small range. But now take a look at this data that I have now. When I ask them their ages, what kind of answers am I getting? What's the range of this data set? Help me think about that. Do you guys remember what range means?
We would say from 16 to 45.
16 to, there's even ones bigger than 45, and James said range is the spread. You're absolutely right, James. So 16, I see some even bigger than 45. Let's see. Oh, look, Olivia's 56. Is there anything bigger than Olivia? No. So 16 to 56, oh my goodness. And I got a lot of numbers in there. There's a lot of variation. Unlike before where I kept having the same answers over and over again, this time I have a lot of different answers. Imagine if I tried to do a bar graph with a 16 and a 17 and an 18 and a 19 and a 20 and it's all the way to 56. It would be really ugly. Okay, so one thing you can do is instead of doing each number or each item set individually, you can use a range. You can group people by a range. Now we're going to go ahead and look at some examples, and this, it doesn't have to be this range, but the way I grouped it was I put all the teenagers together. I did 16 to 19. Then I put all the 20-somethings together, 20 to 29, and the 30-somethings together, and so on and so forth. And so I was able to group how many people are in their teens, how many people are in their 20s, how many are in their 30s, so on and so forth, in order to better organize the information. So let's go ahead and take a look at some examples of that. These types of graphs are known as histograms. And these types of graphs are ones that confuse students a lot. So this is a vocab word that you should know. You should know what a histogram is. A histogram is a type of bar graph. I mean, obviously, look at the bars. But it's a bar graph where the categories are in ranges. And one thing you're going to notice is how close together the data is. Instead of having like a bar and a space and another bar and a space and another bar, you're going to see that my bars are touching. That's a visual clue that I'm actually looking at ranges of data. Notice that here that these rectangles kind of touch each other, and that's that idea that I have a range that's continuous. And we can see there's a couple of different ways we can label it, and that's the only real difference between my two graphs, the way that we label it. In this one, I just labeled the actual range, 16 to 19-year-olds, 20 to 29-year-olds, 30 to 39-year-olds, so on and so forth. But in the second graph, look what I did. And I need you to see how that could look different. I actually have numbers instead of ranges labeled, and you can just see that this one starts at 10 and goes to 20. So that's the 10 to 20 range. And this one starts at 20 and goes to 30, and so on and so forth.
I'm confused about that one.
Yeah, this is the one that confuses most people. You're talking about this labeling, right?
Mm-hmm.
It is confusing because you don't really know, like, does this one stop at 20 or does it start at 20?
Yes.
All you know is that these people in here are between 10 and 20. So the way that I have it organized is, you know, up until you're like 19 and 364 days, you're going to fall in this category. But the second you roll over 20, you're going to be in the next category. This can be a little confusing for people because they're expecting the numbers to be right underneath. So basically what I'm trying to point out is if the two numbers are on either side of your bar, they're actually talking about a range, 20 to 30, instead of just one single number. You can also see a frequency table with ranges. Looks just like the other kind of frequency table, but what's the difference here? Instead of me seeing exactly how many 16-year-olds, exactly how many 17-year-olds, we have again lumped people into a range. So there's all my 16 to 19-year-olds. How many people are in the 16 to 19 range? 25. Does that make sense?
Yes.
This one is a little confusing because this is my data. Instead of knowing exactly what my data is, I don't know exactly. I just know about what my data is because I know what range it's in, but I don't know exactly what it is. Saw a problem the other day that said that it gave someone a frequency table like this, and then it said, what could the median be? Not what is the median, but what could it possibly be? And so the student had to figure out what range the answer was in and see that it could be any number in that range. It could have been, like if that was the median, then it could have been 30, 31, 32, 33. We don't know, but it could be any one of those numbers. And it was a multiple choice, you know, so only one of the things fell within that range. But we don't know exactly what it is because we only have a range of data. And again, I did one where you can see that here's my data and I have two different frequencies. Again, the males and the females, and I can see their ages. So what is the mode of the age ranges in my class? Guys, let's do a mode problem. What is the mode of the age ranges in my class? And you could look at either one of these graphs, it's the same data. Do you remember what mode means? Trendy, trendy, exactly, James. Mode is the most common item. So if I'm asking you, what is the mode of the age ranges in my, or age range in my class, I'm asking you, most of the students are in which age range? Does that make sense? Most of the students are in which age range?
16 and 19.
Exactly. I don't care whether you look at it on this graph. We can see more students are in this age range than any other age range, and it's just as easy to see from here. More students in this age range than any other age range. So yeah, absolutely. The mode here then would be 16 to 19, which feels weird for a mode. I wanted to show you guys a stem and leaf plot. This is one to definitely take notes on because a lot of people don't know about that. So here's my first stem and leaf plot. Notice what it says. It says female GED students by age, but look at how weird the numbers are. Okay, so on the left here, these numbers are known as the stem. The stem is usually the highest place value. This is called a stem and leaf plot. These are the leaves, and this one is the lower place value. So basically, if you put these two numbers together, you'll have the individual items in my data set. Like this one and this set 6 represents a 16-year-old. And then there's another 16-year-old, that one and that 6. And then a 17-year-old and another 17-year-old, and so on and so forth. How many, so I'll ask you a question. How many 19-year-olds are there How many 19-year-old females are there in my GED class?
3.
3, exactly. I'm talking 19, so I want to be in this 110s, and then there's a 119, 2 19s, and 3 19s. Wonderful. This would not be a 19. That's a 49. Looking at this same graph, how many 34-year-old females are there in my class? So go to the 30s row. So this is the 10s, 20s. Here's the 30s. And to find a 34-year-old, you want a 4 in the ones place. So there's one 34-year-old and two 34-year-olds. I can see there's two 34-year-olds in my class. So tell me, how old is the person here?
56.
Exactly, you get it, 56. I did just want to point out to you a few things about this graph. One thing is that the ranges are always based on place value. So I'm always, like in this case, these are all 10s. So I have all my guys in the 10s place group together, my 20s together, my 30s together, my 40s. I wouldn't want a different range system in this. It's always going to be based on the place value. Now, it didn't have to be the 10s. I could have had the hundreds over there if I had a lot of, numbers in the hundreds, or so on and so forth. And the other thing I wanted to point out is that the items are listed in order. If you look at my ones place over here, first I have all the 6s, then all the 7s, then all the 8s, then all the 9s. It's not just any random order. It is in numerical order. That being said, it can happen that you have two different data sets on the same stem and leaf plot. In this case, it's the same exact idea. I have my stems, which is still my 10s place, but these are just my leaves of the females. So here's all my females. So I have, like, we already know this, a 22-year-old female. We can see 22, okay? And then on this side, here's all my males. And I labeled it males. And we can see there's a whole lot of 16-year-old males in the class. How many 16-year-old males are there? Yes, 6, exactly. In the 10s place, that would be a 10 and a 6. So 1, 2, 3, 4, 5, 6 16-year-olds. And it might be a weird looking graph, but it's not a hard graph. Anybody see any strengths or weaknesses about the stem and leaf plot?
Not visual.
Yeah, that's definitely a weakness. It's not super visual. Now, we do still have the length of them, so that's nice. But yeah, it can be really confusing with all those numbers there. How about a benefit, though? Anybody see the benefit that I didn't have in any of the other frequency tables?
No, it just looked messy for me.
Yeah, you don't like it either? Well, here's the benefit. I can see the actual individual scores. With the other ones, I just knew we were in a range. I knew it was between 16 and 19, but I didn't know what the exact scores were. Here, I can see how many students are in the teens, a whole lot of students, but I can also see exactly what their scores are. There's a 16-year-old, another 16-year-old, a 17-year-old. Okay, don't panic. Example 1, it says the table to the right shows a restaurant's projections about hourly kitchen labor. Based on the table, what should they budget for hourly employees' pay each week? Well, here's the thing about the GED. They could ask you anything about a graph. So we really got to get to the point from how's that graph made, what's it look like, to how do I use this information? So what am I asking you to find? I'm asking you to find all the hourly employees' pay for the whole week. So let's take a look at our graph. What do we have going on here? Let's look at the headings so we know what's going on in this graph. So we can see that we have some hourly positions here. And then we have a number of employees. A number of employees. That sounds like a frequency to me. How many guys are getting something? Then we also have a pay rate, how much those people are paid. And then we have hours per week. Hours per week, how many hours they're working in a week. Again, that's another frequency, you know, how many hours they work in a week, okay? So there's some repetition going on in this graph. I have things happening again and again. So let's look at the pastry chef, first of all. There's only one of him, so this should be easy. This gentleman makes $22 an hour and works for 40 hours a week. How much money should I budget for the pastry chef?
$22 times 40.
Absolutely. Frequency is the number of times something happens. So Maricel is right. We could just take that $22 an hour, multiply by that frequency of working 40 hours a week, and 22 times 40 would give me $880 that I need to budget for that pastry chef. Now let's go ahead and budget for our bakers. again, we have that they're making $15 an hour for 30 hours. I can definitely multiply that. But notice that there's not just one baker anymore, is there? Now I got a budget for 3 bakers. I have that $15 an hour times 30 hours happening 3 times if I have 3 different bakers. So guess what? I'm going to multiply all those numbers. 3 times 15 times 30. And I get $1,350. 8 times 14 times 35. Each one of the 8 line cooks, it makes $14 an hour for 35 hours. That's another $3,920 to budget for my line cooks. And we're going to keep going like that. 10 prep cooks, that's the frequency at which they're making $11.50 an hour times 30 hours a piece. And that'll be $3,450. And now for our dishwashers, there's 8 of them, so we're going to multiply that by $10 an hour times 20 hours a piece. And I need to budget $1,600 for my dishwashers. But I still don't have my total for all the hourly employees. Right now I have the pastry chef, the bakers, the line cooks, the prep cooks, and the dishwashers all separately. How could I get the grand total? Any ideas? Add it. Exactly. So I'll take that 880, 1350. This isn't repetition, so I'm not multiplying. This is just a bunch of random numbers I want to total, so I'm going to go ahead and add. But I got $11,200 budget for my hourly employees each week. I got to sell a lot of burgers. Yeah, maybe not. Not if there's a pastry chef. Maybe I have to sell a lot of steak. This is so GED typical. I just got to tell you. Word problem combined with table, combined with lots of data. But definitely everyone probably realized, man, do I want a calculator for a problem like this? And if you did have a problem like this on the GED, you would absolutely have the calculator. So B says, how much more does a baker make in a week than a prep cook makes in a week? Oh, James said the most brilliant thing. James, you're absolutely right. When I was a restaurant manager, which is how I know about this table right here, I did use Excel for this. James says you could just use Excel for this, but you can only use Excel if you know how to write a mathematical formula. Excel is based on understanding algebra, but Excel makes all these things so much easier. It really does. So let's look at B. It says, how much more does a baker make in a week than a prep cook makes in a week? So how much more? I'm comparing. I'm looking for the difference. I don't care whether I say how much more or how much less. I'm still comparing. I'm still looking for a difference. You guys know mathematically what operation we use to find the difference between things? What operation do I use for differences? Is that add, subtract, multiply, or divide? So I teach this on the very first day of class when we talk about the basic operations. Difference when you're comparing those 2 numbers, how much more or how much less, is a subtraction problem. So they're asking me to subtract. Now, what are they asking me to subtract? They're asking me to subtract how much a baker makes in a week, so a week for a baker, and how much a prep cook makes in a week, so a week of pay for a prep cook. I kind of have a plan now for what I'm going to do. Okay, wonderful. So let's go find this number first. Let's go find how much a baker makes in a week. Any ideas? How much does a baker make in a week?
$450.
$450, absolutely. Maricela said that baker makes $15 an hour times 30 hours, $450. Why didn't I multiply by 3? Well, I'm just looking at a baker, not all the bakers. I don't care how much all the bakers make. I care how much a single solitary baker makes. So that's $450. And now I want to compare that. I want to find the difference between that and a week for a prep cook. So how much does a prep cook make in a week? So we're going to do $11.50 an hour times 30 hours. And we should get
$345.
$345. There we go. Those are the 2 numbers we're comparing. Okay, so if I want to find the difference between those 2 numbers, those 2 amounts, then I will subtract them. 450 minus 345 is $105. And do remember that difference is always positive. So even if you had them in the wrong order and you subtracted and got negative $105, you would just drop that negative sign and say $105. Difference is always positive. Example 2, let's look at some dot plots, okay? So it says a group of students was polled to determine the number of college credits they were enrolled in that semester. Their answers were as follows, and there's a bunch of data. Plot the data on the number line using an X to represent each data item. So luckily, yay, this is one of the simpler problems on the GED, problem types, but I don't want you to not know what you're doing when you get there or freak out. So if you had this on the GED, it would probably be a hotspot question where you just need a mouse click to make things work. And we are going to use an X to represent each data item. So you just click to drop an X above each thing. So let's go ahead and graph our data. So there's a 9. So I'll put a little X above the 9. And I'm sorry, my picture looks a little hard to read. This is 6, 7, 8, 9. Okay, so now I graphed a 9. Okay, next item I'm going to graph is a 12 and a 10, and so on and so forth. Now, when I need another 9, I just put it on top. And notice how I'm crossing out each one as I go. That's because I've missed data way too many times. But unfortunately, when you're doing it on the GED, you won't be able to cross things out. So it'd be a good idea to go back and count or something like that to make sure that you got all your data items. Easy, right? Easy. So let's take a look at B. It says, if a full-time student is one taking 9 or more credits, what fraction of the polled students are enrolled full-time? What am I asking you to do? What's the question here? I see some if information, if a full-time student is one taking 9 or more credits. That's just more information for me. But now I see this question word, what? And that's that signal here that my question is starting. So what fraction of the polled students are enrolled full-time? So they're asking me to make a fraction. Now, when you're making a fraction, remember that one way to think of a fraction is by you thinking of the fraction bar as out of, the words out of. So we'll do the part we're talking about out of the total. So a full-time student is one taking 9 or more credits. And I want to know what fraction of the polled students are enrolled full-time. So the part I'm looking at is the full-time students. So guys, how many full-time students are there?
9.
There are 9, absolutely. 1, 2, 3, 4, 5, 6, 7, 8, 9 students taking 9 or more credits. So 9 students enrolled full-time. I'll put the 9 up there. That's the part of the piece I was talking about. Now, we said with a fraction, it's a part out of a total. So how many total students are there?
12.
12. I'm counting the X's. The X's are the students. Nice job. So 12 total X's, 12 total students. So 9 out of 12. Now, this is a correct answer, but it's not done yet. Does anybody know what I always must do when I have a fraction answer? All final fraction answers must be reduced to lowest terms. I want you to make sure they're in lowest terms. Now, the good news is, even if you hate fractions, you've never done fractions, and fractions make you want to cry and puke simultaneously, your TI doesn't feel that way about fractions. It loves fractions. You can reduce fractions to lowest terms in your calculator by simply typing in the fraction. So I will do that. I will type 9, and then the N over D button for the fraction, and then 12. And 9/12 is now in my calculator. I press enter, and the calculator doesn't even need to be told. It knows that final fraction answers must be reduced, and it spits out 3/4, the reduced form of 9/12. 9/12 in lowest terms, okay? So don't panic about the fractions. Use your TI to your advantage. What kind of a graph is this, you guys? You remember what this one was called with the pictures?
Pictograph.
It's a pictograph, exactly. Okay, so we're looking at a pictograph now. An educational company is trying to determine recent GED graduates' preferred study methods. They found the results of one study. My English is confusing here. I think I meant to say GED students when you confuse yourself. Okay, they found the results of one study of GED students in the pictograph. So what is the mode of the data set? First thing I'm asking you is about mode. Here's my pictograph. Interesting question. What does mode mean? Remind me again. Trendy. James says it's trendy. That's right. It's the most common item in the data set. So let's go ahead and look at this graph. This graph is all the information we have about this data set, and ask ourselves, what is the most common item in the data set? Now, the data is what? The data is a bunch of students' preferred study methods. So what is the most common preferred study method?
Web page, YouTube.
Exactly right. It looks like most of these students, they talked to preferred using web pages and YouTube to study with. And James is like, yep, Khan Academy is great. That's definitely a web page you could use to study for the GED. Okay, so what is the mode of the data set? It doesn't have to be a number. It really is, in this case, web page or data set or YouTube, because that was the most common item. Now, I really want to do this one, B, because B is something that students confuse a lot, not because of the graph, because they don't understand the wording, okay? So B says about how many times more people prefer a web page or YouTube to traditional GED books. So we're comparing web page or YouTube, so there's the web page or YouTube, to traditional GED books. And we're looking about how many times more.
I would say 330, 340.
And I would agree with you if it said how many more people. But Maricela, do you see how it says how many times more?
Yeah, I see.
Yeah, we're saying the GED book. So about how many GED people prefer GED books, you think, Maricela? Just look at this column for me. About how many people are in just that column?
130, I would say.
Maybe 130. So I'm asking myself 130 times what? How many times more is equal to this other one? How many times would I have to have this GED books in order to be equal to the web pages or YouTube? So how many people are we looking at there for the web pages or YouTube? So how many students? 100, 200, 300, 400, and I don't know, what you think? 450 maybe?
Yeah.
Maybe 440, hard to tell. So Maricela is guessing that 130, you would have to multiply that by about 3 to get to 440. Now, mathematically, if you don't know how to move forwards, if you don't know what you're timesing by, you can move backwards, you can divide. So that's what I'm gonna do. I'm gonna take 440, and I'm gonna divide by the number I do know, 130, and figure out that Maricela is about right. I got about 3.3. So yeah, about 3 times more. And it does say about. So if this were on the GED, it would be a multiple choice answer with rounded answers. So about 3 times more. You're absolutely right. Maricela, you didn't do this math. So how did you know it was about 3 times more?
Because I would see the pictures.
Yeah, that's what we were talking about, that visual comparison. You can use your eyes to imagine. If I had this picture drawn 3 times, you know, I'd end up with 3 full lightning bolts, and then putting lightning bolts together, yeah, I'd get real close to this. And that's what we were talking about when it's nice for visual comparison. And I have the very nastiest bar graph I could find, because GED teachers have a problem. I'm going to tell you what our problem is. We show you all these nice, simple bar graphs in class, and you guys are like, bar graphs are easy. And then you go to your GED and you get gross stuff like this, and you lose your minds. So we're going to look at some pretty tricky problems, okay? So first of all, let's just figure out what's going on in our bar graph. Let's read our axes. On this axis, we see number of cars or motorcycles. And then on this axis, I don't have a label down here on the bottom, but I can see what these things are. What are these things if you start reading these words? India, China, Japan, Indonesia.
The places.
Yeah, countries, places, exactly. And then look at this, I actually have another axis, another vertical axis on this side that says population in millions, okay? So we have population in millions. Okay, so if you look here, you can also see some colors on our graph. I have cars, motorcycle, and that population's in millions. So the light blue represents cars, the dark blue represents motorcycles, and the red represents population in millions. Okay, now let's take a look at our questions. This is what I expect on the GED, more reasoning type questions with these bar graphs. Can be really confusing. So let's take a look. It says, in which countries are people least likely to own a vehicle? In which countries are people least likely to own a vehicle? Okay.
Myanmar. I don't know if I said it right.
Yeah. I don't know if you said it right either, but I'm looking at it. Okay, so what about this made you think they're less likely to own a vehicle?
Because I don't see light blue.
You don't see light blue. Okay, so both cars and motorcycles count as vehicles. So I see some blue, you know, any blue would be a vehicle. But one thing I notice is that the blue is underneath the red. Do you see that?
Yes.
Yeah. So definitely, I think you're right. We have cars under these population here because our population is the red. Anybody else see another country that looks like we have people are less likely to own a vehicle?
Grace looks very close.
Greece.
Greece.
So even though there's not a lot of vehicles in Greece, take a look at where the population is, where the red line is.
Yeah.
Do you see how the red line is underneath? So even though I don't have many vehicles, I also have a small population, okay? So not many vehicles, but not many people. And so I would have, my people, even though there's not that many vehicles, there's also not that many people. So probably people mostly own a vehicle. So it's really a comparison between the red here and the blue. Look for high reds with low blues. That's how you'll know that people are not that likely to own a vehicle, because the population, the red, is so much higher than the cars or motorcycles, the blue. Does that make sense?
Yes.
Okay, do you see any that are like that? I see a few. Take a look at Iran. Do you see that population well above the vehicles?
Yes.
I'm comparing the red to the blue. Okay. I see another one, India. Now you might be saying, but Kate, India has a lot of vehicles. Look how high those blues are. Yeah, they have a lot of vehicles, but look how many people they have.
So the other one would be China.
Yes, absolutely. China's another one. People are less likely to own a vehicle. Does that make sense?
Yes.
Okay, I see another one where people are less likely to own a vehicle.
Indonesia.
Indonesia. Yes, absolutely. So even though I can't figure out the exact numbers based on this graph, I can do some really good approximation based on these relationships. Which country has the highest number of motorcycles per person? The highest number of motorcycles per person. I'll actually accept two answers. If this was on the GED, it would definitely be multiple choice. James, is that an answer to my question, India? So I agree, James, that India and China have a lot of motorcycles, but they also have a ton of people, So I do not think that they have the highest number per person. The highest, I can try to estimate what it would be. Let's see. So it's about, I don't know, 38 million motorcycles per, what's my population there? 380 million. I could cancel out all these zeros. Oh my goodness. And I would see that we have 38 out of 380, which is about a 1 to 10 ratio. Not that high, 1 out of 10 people with a motorcycle. There's definitely higher ones here. Can you see where compare the dark blue, that's the motorcycles, to the red, and look for ones where the dark blue gets really close to the red or even surpasses it. I can tell that this problem is really confusing us. So if I say which country has the highest number of motorcycles per person, that means I want my motorcycles to be higher as compared to my people to be lower. So my motorcycles here are the dark blue, so I want the dark blue to be high. As compared to my population is the red. So I want the population to be lower. Okay, that's what I mean by the highest number of motorcycles per person. So here's a great example, Italy. Take a look. And Italy, that dark blue is lining right up with that red line. Can you see it?
Yes.
Yeah, so that's a higher proportion. And there's two that are even higher than that. Can you see the ones where the dark blue are even higher than the red? In which two countries is the dark blue even higher than the red?
Malaysia.
Malaysia, there you go. See that dark blue exceeding that red? That's the sign that it's a high proportion, even though it's not a high amount on its own. When you compare the two, you end up with more motorcycles than people. Or it's not really more motorcycles than people because we have two different axes, but a higher relationship of motorcycles to people. There's one more like that. Which one's the other one like that?
Japan.
Oh, Japan's so close. There's one higher than Japan, though. Where the motorcycles are definitely higher than the people in a higher relationship. I'm looking at Thailand. Can you see how the dark blue is above the red in that one?
Yes.
Yes.
Yes. Ooh, that was a hard question, huh?
Yes.
Well, I'm glad I included it because that would be the kind of stuff I would expect from the GED. So let's look at one more like that. So hopefully it'll make a little more sense here. So the last one says, which countries have the highest ratio of cars to motorcycles? And again, I'm saying countries because there's not necessarily one right answer. If this was on the GED, it'd definitely be multiple choice. But which countries have the highest ratio of cars to motorcycles? So now I'm comparing cars. Cars are light blue. I want that one to be high, highest ratio of cars to motorcycles. So I want the motorcycles to be a lot less. So I want the light blue to be a lot more than the dark blue. That's what I'm saying, the highest ratio of cars to motorcycles. Does that make sense?
Yes.
So find me a country where the light blue is a lot more than the dark blue. There's quite a few of them.
There's the United States.
Oh, for sure. Much higher population of cars to motorcycles in the United States. But it's not the only good answer. Anybody else? Something with a high proportion of cars to motorcycles.
Japan.
Let me see, Japan. Japan, definitely. Let's see, for this one dark blue, there's about 3 light blue. Yeah, it's pretty high. It's pretty high. There's other ones that might even be higher. Anybody else see another one?
France.
France, for sure. I bet I could fit 5 or 6 of these dark blues in the light blue space. Yes, absolutely. How about another one?
Germany.
Germany, absolutely. Now you're getting how to look at this. It's a relationship between two things. Very nice. And you know, it'll take you 3-4 minutes just to figure out what the heck is going on in this graph. You know, so if I had something like this on the test, I would probably skip it and come back to it because the last thing you want to do is spend 10 minutes on a question and get yourself so frustrated that everything else seems harder. So this is one of those ones to tag and flag, come back to it at the end, take your time, and don't let it stress you out, but kind of go through this reasoning process. I think this is my last example. Hallelujah, guys, class is almost done. Oh, happy day. Okay, so example 5 here. Mrs. P's 5th grade class is competing to sell the most candy bars for a fundraiser. The stem and leaf plot to the right shows how many bars each student has sold. So my first question, what is the range in the number of bars sold? What is the range, and the range of what in the number of bars sold? Remember, in a stem and leaf plot, you put these two numbers together. So this isn't 2, this is 20. This is our tens place. In this case, this is our ones place. So 20 is the lowest number of bars somebody's sold. What's the highest number? 10 tens. How much is 10 tens? Yeah, that's 100, and careful, that's not a 1, James, that's just the bar. So this is 102. 102. We have 10 tens and a 2, 102. Does that make sense?
Mm-hmm.
Yeah, tricky. So if you do range, we do it by doing high minus low. So I'll take my 102, I'll minus my 20, and that's a range of what? 82. That's a very big range of bars sold. Now, again, these are simple questions, but this is a tricky kind of graph to read. So B says, how many students have sold 50 or more bars? How many students have sold 50 or more bars? How many bars has this student sold right here?
20.
20. Okay, wonderful. So they did not sell 50 or more bars, so we won't count them. How about this next row? This represents 30, and then I have a 32, and then I have a 35. So right there I have 3 students. Did any of them sell 50 or more bars?
Okay, I get it now.
So what row am I looking at here, Maricela? This is the tens place, so this will be 50 something. So this first guy will be 51. That's 1 student right there. There's 2 students, 53. Okay, so how many total students have sold 50 or more bars then?
There's 20 students.
Exactly. So 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 students have sold 50 or more bars. So this is the range, but these are all the students in that range. So there's 9 and 6 more students, 3 more, 1 more, and 1 more student. This last weird question I have for you, C, says, how many more bars would the second place student have to sell in order to surpass the first place student? And I think this is just like so GED typical to ask mean, weird questions that we really have to interpret what the heck are they asking. So I'm saying, how many more bars would the second place student need to sell? in order to surpass, she wants to surpass. Do you guys know what the word surpass means?
Yeah, more.
Yeah, get more than the first place student. So let's start with first place. Who's winning? Who's sold the most candy bars?
102.
102. There we go. There's Mr. First Place. So first place right now has sold 102 candy bars. Now let's look at second place. The next highest one
88.
is 8. There we go. Now we're making sense of this graph. So my first place is 102. My second place is 88. I didn't have anybody in the 90s. That's why that's second place. Okay, so how many bars would Mr. Second Place have to sell in order to surpass the first place? In order to surpass him, I only have to sell one more than him. Okay, so I have to get to at least 103. So I want 103. I'm only at 88 right now. Let's find the difference between those two numbers. 103 minus 88 means I have to sell 15 more bars just to surpass him, get right past him. Okay, then I guess we're done. Thank you so much for coming to class today. You know that I love not talking to myself. It's my favorite. And hopefully I will see you next week when we look at mean, median, mode, and range from a frequency table.